Hi everyone, welcome back to our channel. Today we are going to see the remaining part of AC excitation of series RL circuit, and we are finding the power and the power factor. Okay, so the formula for power we have power is equal to instantaneous voltage multiplied with instantaneous current. The instantaneous voltage we can write down it as Vm into sine of omega t, and current you can write it as Im sine of omega t minus 5. So in order to combine all this, I can take Vm into Im and the remaining. So this is like the formula. We know that since 2 sine A sine B is equal to cos of A minus B plus cos A plus B. Okay, so here this is minus. Okay, cos A minus B minus cos A plus B. Okay, so but here we have only sin A sin B. I can write down it as a sin A sin B. We can write down it as 1 by 2 into cos of A minus B minus cos A plus B. Okay, so when you perform it, then you can see here, so this is sine A and this is sine B. So sine A sine B we can write down it as 1 by 2 into cos of A minus B. What is the A value? Omega t minus B, omega t minus 5. Okay, this is cos A minus B minus cos A plus B. A plus B is omega t plus omega t minus 5. Okay, this is what you are going to get. So this 2 we can write on it as Vm by root 2 into Im by root 2. Root 2 into root 2 is again 2. So which is cos omega t. So here you can write on it as cos omega t minus omega t plus 5 minus cos of 2 omega t minus 5. So cos of 270 degrees, this will try to become as a zero value. I mean this double the frequency will try to become as 0. Okay, so now we have only this term, so this I can write on it as omega t is complete double the frequency. I mean term will become as 0. So here Vm by root 2 we can write on it as capital letter V, and this as capital letter I, and this as cos phi. So this capital letter V is called RMS quantity, this capital letter I is called RMS quantity of current, and the formula for active power P is equal to VI cos phi, and the units are watts, or the units are kilowatts. This is how to find out the power drawn by an series RL circuit excited with an AC supply. Now let's try to find out how to draw these waveforms. Okay, so already we have these two set of waveforms. How to draw these two waveforms? Let's try to do. So waveforms is very important to understand waveforms of instantaneous voltage and instantaneous current. Instantaneous voltage is given by Vm sine omega t. Instantaneous current is given by Im sine omega t minus phi. Okay, so when you try to draw it, it's very simple. You see here, we have the x-axis with omega t. So the units of omega t are nothing but angular velocity, which is nothing but radian per second, and the units of time is second. Second will cancel, so it is like omega t, or it may be in radian, or it may be in degree. Okay, so on the x-axis we are going to have instantaneous voltage or instantaneous current. Let's try to see here. Instantaneous voltage is having a maximum value of Vm, and which is a sinusoidal function varying with respect to omega t. So I am going to draw the waveform like this. Okay, so this is the instantaneous waveform. Okay, so exactly how to draw, but no issue, just I'm mapping. This is sine 0 degrees, this is sine 90 degrees, this is sine 180 degrees. Just kind of understand, this is 270 degrees, this is 360 degrees. This is the waveform of small v equal to maximum. V maximum is the maximum magnitude of the voltage, that is equal to 1. So V maximum is equal to V maximum into sine omega t. And now we need to draw the waveform of a current. How to draw the waveform of current? Current I is equal to omega t, same. So you see here, this minus t indicates that at t equal to 0, current I should have negative magnitude, then only we will get this minus 5. Okay, so this is that instant. So in order to differentiate it, I am going to draw it with an red color. It should how much magnitude? Negative magnitude. Let us assume that somewhere it is starting with minus 90 here, and the waveform is like this. It goes and it reaches 90. Okay, and these are the 2 points. The positive cycle, it will go like this and it will try to close. So this is the magnitude of the waveform. Here you can see here the magnitude is how much? Minus 1. It's nothing but Vm. Okay, minus Vm. So you can see this waveform. This waveform is maintaining a magnitude of Im, and this is also a sinusoidal function with minus 5. Okay, so this is like if you perform phi equal to 90, then you are going to get minus Im cos of omega t. That's why the phase difference it maintains with an angle of 90 degrees. Okay, this is how to draw the instantaneous voltage and current. If you want to draw the power, I can show you the power with more clarity also. So here voltage is positive and current is negative. So positive into negative, then you are going to get the negative power like this. Okay, and you can see here voltage is positive and current is also positive. Then the waveform is like this with higher magnitude. Here voltage is positive and current is negative. Sorry, voltage current is positive, voltage is negative. So plus into minus, you will get the power like this. Okay, so like this it continues another cycle. Here the waveform which is shown in dark color line is nothing but the power wave. Okay, so again the waveform will continue to go like this. Okay, and this is negative and this is also negative, and the waveform will continue like this. So this dark color line which I am showing with higher magnitude is the magnitude of power for different. So these are the waveforms for voltage, current, as well as for the powers. And now we need to understand what is the importance of power factor. So we'll try to understand this power factor in the upcoming video. Thank you for watching. We'll meet in the another video. So if you feel the content is useful, please like the video, share with your friends, and still if you have any doubts, let me know in the comment section. Thank you for watching. We'll meet in the another video. If you're watching the channel for the first time, subscribe to my channel with the name KV Tulsi Ram. Thank you for listening the content patiently. Yours Ram.